Okay, today we're doing 8.5 using intercept form. So we're going to be looking at intercept form now. So we've learned our standard form of quadratic equations. The last lesson we had our vertex form, and now we're going to be looking at intercept form. So intercept form is nice because it tells us our x-intercepts. So find the intercepts, same thing as the solutions, the roots, the zeros, the factors, all those mean the same thing. So we're finding where does it cross your x-axis. Okay, so if we want to know where it crosses our x-axis, and it is in this format here, our a term still represents the exact same thing, and this time p and q represent our intercepts, and it's always the opposite of p and the opposite of q are our two intercepts, and that's because the formula has subtraction signs in it. So if we're subtracting a 2, that means we actually have the number 2, which would be a positive 2. If we're adding a 3, that means we're actually subtracting a negative 3, which would mean we would have a negative 3. So always the opposite of what number is in your parentheses. So those are your two intercepts. And then to find your axis of symmetry, well, your axis of symmetry always goes halfway through where your two intercepts are. Therefore, it's going to be the average of those two. So you would do the opposite of your p term plus the opposite of your q term, and then divide that answer by 2, and that would give you where your axis of symmetry is. So a term still tells us how wide it is. If a term is a positive number, it's opening up. Your a term is a negative number. It's that reflection over the x-axis that's opening down. All right, so factors, zeros, roots, solutions, intercepts, any factor of this, it's always the opposite of that number that ends up being the 0 or the factor, the solution, or the intercepts. And again, that's because if we set it equal to 0 and solve it, we add an n on both sides, we get x is equal to n. So that's why it's always the opposite of each of those numbers. All right, so let's take a look at our examples. So it says to find the x-intercepts. So to find the x-intercepts, it's the opposite of each of these numbers. So my two x-intercepts would be at negative 2 and a positive 4. To find the axis of symmetry, I will average those two numbers. So negative 2 plus 4 divide by 2. So negative 2 plus 4 is 2. 2 divided by 2 is 1. So these are my intercepts, and this is my axis of symmetry. Try number 2. Okay, so for this one, the a term, again, doesn't affect any of those things. So my x-intercepts are going to be at a positive 2 and a positive 3. When I average those two, I get 2.5. So my axis of symmetry is the equation x equals 2.5, and I've got two intercepts at 2 and at 3. All right, so then what do we do if we're asked to graph it? Well, we're going to start by finding our intercepts, finding our axis of symmetry, and then we're going to need our vertex, because if we want to know how far up or down it is, that's an important point. All right, so my intercepts are going to be at negative 5 and a negative 1. So I can go ahead and graph the parts that I already know. So when x is 1, 2, 3, 4, 5, negative 5, and when x is at a negative 1. If I can find my vertex, that'll give me enough information that I can graph it. So my axis of symmetry I find by averaging negative 5 and negative 1. So negative 5 plus the negative 1 divided by 2. Negative 6 divided by 2 is negative 3. So I know my axis of symmetry is right here at negative 3. If I can find how high up or down that vertex is, then I will have my graph. So I just need to plug in x is negative 3. So I'm finding m of negative 3. So that means I'm doing negative 3 plus 5, and then negative 3 plus 1. So when I simplify that, negative 3 plus 5 is 2. Negative 3 plus 1 is 2, and 2 times 2 is 4, which means my vertex is at the point negative 3, 4. Negative 3 times 1 is negative 2. Negative 2 times 2 is a negative 4. So it's at negative 3, negative 4, excuse me. Okay, and then if I connect my points, I have my graph. All right, then it says to describe the domain and the range. So domain is going to be all real numbers. Remember, that's always the case for all quadratic functions. That hasn't changed just because we're looking at the equation in a different form. The range, well, the lowest point it goes to is -4, and it's going up from there, so y has to be greater than or equal to -4. Go ahead and try number 4 and see how you do. Pause the video and come back when you've got it. All right, so I know my intercepts are going to be at a +3 and a +1. To find my axis of symmetry, I'm going to do 3 plus 1 and divide by 2, which gives me 2. So I can go ahead and graph those things. So it intercepts at 1 and at 3. My axis of symmetry is going to be at 2. And then I just need to find how high or low that vertex is. All right, so if I plug in a 2 for my x in both of my spots and simplify. So I have -4 times -1 times +1, which would give me a +4. So my vertex is at 2, 4. And then I can connect my points, and I've got my graph. So I know where my 2 intercepts are. I know where my vertex is at. I found my axis of symmetry. I know that it is opening down because of that negative, and it matches everything we've already learned about our graphs. So my domain, again, is going to be all real numbers. My range. So this time it has a highest point. The highest point is at +4, and it's going down from there, so y has to be less than or equal to 4. If it asks you to find your axis of symmetry and your x-intercepts on a problem like number 5, it's not given to you in vertex form. But guess what? Vertex form is just factored form. So it's easy to put it into vertex form by factoring it. So this is the difference of 2 perfect squares. We learned a rule for that. The rule was take the square root of each of them, make one positive and one negative. If you didn't remember how to factor it that way, remember you can do your a times your c on the top and your b on bottom. The 2 numbers that multiply to give you -4 and add to give you 0 and divide by your a term. Either way, you can get it factored. And now you've got it in factored form. So same thing for number 6. If you want to put it in factored form so you can find those intercepts, if you prefer doing it that versus setting up your XY table, that's great. Because remember on this one, to find your XY table, you'd first have to do the opposite of B divided by 2 times A. That would give you the middle number in your table. Then you'd make your table from here with that being the number that goes in that spot. You'd plug in all of your numbers. I think factoring it first sometimes could be faster because then you're only having to find your 2 intercepts and then your vertex. But if it doesn't tell you which way to do it, you can choose. All right, so if it says to find the zeros of the function, guess what? We're just tying it back in. We're doing the exact same thing. So start by factoring it. So they have a GCF that I can factor out, and now it's the difference of 2 perfect squares. Okay? So when I'm thinking about it, I can think about my graph. My intercepts would be at the opposite of this one, comma this one, which is found by setting each of them equal to 0 and solving them. So my zeros are the same thing as my solutions, are the same thing as my x-intercepts. It's 1 and -1. If you want to use the plus minus sign for 1, that would be the same thing. So you could either have it this way or this way. Either one, it doesn't matter which one you have. All right, so then if it says on number 9 to use the zeros to graph it, again, same thing. Factor it. Once you've got it factored, then you just need your vertex and your 2 intercepts, and you're good to go. So intercept form is one that we've actually dealt with before. We've called it factored form, and now it's just tying that into what does the graph look like. All right, take a second, write your summary, mark anything you have questions on, and come to class prepared to get those questions answered.